So I'm Jeff Green from Symantec. We are here to talk about IoT threats and solutions. We have a good panel of folks that will bring a diverse viewpoint coming at it from a variety of angles. Immediately to my left is Kat Megas, who is the Program Manager for Cybersecurity for the IoT Program and Commercial Adoption Lead for the Trusted Identity Group at NIST. Next to Kat is Chris Eng, who's the Vice President of Research at Veracode. And then Arabella Hallowell, the Senior Director for Advanced Threat Protection and Marketing at Arbor Networks. And last but not least, Sean Cooley, the Vice President and Chief Technology Officer of IoT and Industries at Cisco. If you want more on background, you can read about it in the flyers that have come out. So we're going to jump right in. A lot of things to talk about. The panel is called IoT Threats and Solutions. And 5 years ago, really, you started to hear the phrase Internet of Things a lot more. Shortly thereafter, you started to hear about the potential threats posed by the Internet of Things. But one thing that I think most folks who work in this space know is it's not like connected devices were new, and it's not like the threats were new. So I thought it would be a good place to start to get a sense from our panelists on just how real, how they scope it, and in particular in what sectors they think it is a particular issue. We can talk about IoT, and you read about the Reaper, the Mirai botnet, which are connected DVRs and security cameras, but is that really an area? How is it different from healthcare? Is it different in automotive? Even within a sector like healthcare, is a Fitbit different from a pacemaker when it comes to the security implications, both in developing and securing? So when we talked ahead of the panel today, we talked about trying to narrow it down because broad pronouncements about IoT are pretty tough because IoT has become almost a boundless phrase at this point. So to kick it off, just go down the panel. I'm curious whether folks view IoT threat that we've been reading a lot about. Are we living Y2K all over again in the sense that are we overhyping a risk? Or is it a real threat that has been or can be mitigated? Or is it a little bit of both? And if you can try to put it into some context as you discussed, that would be great. So first, Kat.
So I don't know if I can, at this point in time, call judgment on whether it's overhyped or not overhyped. I would say when we were dealing with Y2K, it fell into that category of we knew what we didn't know. There's we know what we know and the things that we know we don't know. But I think with IoT, I think we're still in we don't know what we don't know. I think we're still uncovering just because of the scale and the breadth that IoT encompasses, the scope. I'm not even sure we've been able to define it yet, and I think it's continuing to evolve, and we want to see that innovation. But I think it would be difficult at this time to say whether it's overhyped.
Chris, thoughts?
Yeah, I think I would generally agree with, when you're talking about the scope of the problem with Y2K, we knew very clearly what the problem was, right? It was a very specific coding issue. And this, we're just talking about all of security for every connected device, basically, which is far more broad. The analogy is interesting because we are in a sort of Y2K situation in the sense that IoT security is about where the rest of software security was in 1999. It's about 20 years, I would say, behind. When we look at the types of vulnerabilities that are being found in those devices, when we look at Mirai, which was attacking devices using hard-coded passwords, I mean, we've known forever to get rid of those things, right? And when you're doing a penetration test in the late 90s, you'd find databases connected to the internet with default passwords, and we've managed to not eradicate, but get rid of a lot of those sorts of things. So the maturity level of IoT security is about where we were at that time. And seeing the sophistication and the pace that the attacks are growing. So you have Mirai, and then it was open sourced, and then people tweak that, and then you get Reaper, and the rate that the devices are able to get taken over and amplify attacks is a little bit troubling. So I don't know that everything in security is overhyped, isn't it? So it's a little bit overhyped, but there's a real problem there, and it's getting serious pretty quickly.
I want to follow up, though. You talked about we are in security-wise with connected devices where we were software 20 years ago. Do you think the proliferation of devices, though, is growing faster than the pace of software usage was 20 years ago? I mean, in the sense that do we need to move faster than we did because the scope is growing that much quicker?
It's growing pretty quickly, but I mean, in general, software is growing immensely fast, right? Every company is becoming a software company, and every device is running on software, whether it's your car or your tractor, or your webcam. So I don't know that the pace is necessarily out of control. It's been a pretty quick pace all along, but it's interesting how quickly the attacks are evolving. I think that's sort of the interesting angle.
Arabella?
Yeah, I mean, in terms of, I guess, the question, which is what's new, what's not new, I think as Chris sort of eloquently put, when you look at what we know today, which isn't necessarily everything, we know that the vectors in many ways are similar, so it's even looking at Reaper, it's relatively well-known standard vulnerabilities, it's sort of security basics. But I think that when you look at the specter of IoT, the actual scale, the ramifications are fundamentally different when you just look at the scope of what could now be controlled by forces we don't know and fully understand. And also, I think what is a real departure for IoT is it has massive repercussions for society because it can cause much more physical harm than other types of, I'll call it, security breaches and incidents that we've seen of the past. Yes, people suffer when their data is lost or stolen. Companies suffer when their IP is stolen or websites go down. But when you're talking about the fundamental health and safety of people you love, that just changes the equation. And I think the stakes have changed really significantly when it comes to IoT.
Sean?
Yeah, so I think to scope the problem or the questions that you asked here, so we typically look at this at Cisco as sort of two buckets. One is the general compute devices, laptops, mobile devices, servers, the existing, the things that we had been connecting to the network forever. For us, IoT is everything else. They're the purpose-built, single-use devices that usually do one task very predictably. I mean, as far as the Y2K question, I think for as much hype as we hear within the industry, when I go out and talk to customers, small manufacturing companies, small industrial companies that are connecting devices, it's underhyped. I mean, they still don't fully recognize the potential for what damage can be done when these devices are taken over and used against them. And I think that the sort of big botnets that we've seen, and even the vigilante botnets that we're seeing right now, like Hajime, I mean, they're using very simple exploits on these devices. These aren't complicated attacks. Stuxnet, for example, was a very complicated attack and led to a kinetic result, right? There was an explosion because of that. The things that we're seeing today, I think, are very early days for attacks on IoT.
You mentioned Stuxnet, and we had some discussion about Lieberman-Collins before. So, full disclosure, I worked on that bill. And one of the questions we would get was, well, how would this bill have stopped Lieberman-Collins or stopped Stuxnet? And our answer was, it would be a great day when it would take a Stuxnet level of effort to compromise control systems or other connected devices. And I think Sean just spoke to that, and Mirai and Reaper show that. On that point, and Chris, picking up on what you talked about with we're facing massive DDoS attacks because of hard-coded or default passwords. Where does the responsibility lie in the ecosystem, starting with manufacturer to software developer to distributor to individual with connected device to company being DDoSed? How can we somehow break this chain, and where do you think the responsibility should begin? And probably more in one place, and then other folks.
Yeah, I think everybody shares some responsibility for it. It's going to be impossible to solve all in one place, right? Just like you can never get to 100% security for any infrastructure or piece of software, you can't put all of the onus on one part of the ecosystem to solve that. Vendors, I mean, certainly have a responsibility to build more securely, right? But the economics have to be there. And again, so many definitions for IoT, right? But when we're talking about the low-cost interconnected devices that are viewed as disposable, that are meant to be used for 1 or 2 years, and then they never get, they don't get patched because they're not intended to be around for that long. That's something that has to be thought about, because what motivation do those vendors have to really spend a lot of money on those devices? It could take the manufacturing cost from $10 to $15 or something like that, right? You have the whole patching conversation. Do they need to be patchable? Probably yes. Do they need to be? Is it on the vendors to auto patch them like web browsers do, and to protect the consumer? Don't know. That's a tricky topic, right? Because again, you look at their infrastructure and think about attacks like the ME doc, where the Ukrainian people using that software were exploited because of the auto-updating functionality in that software. And that was a case where their bad software update infrastructure was exploited to push that stuff down without consumers knowing it. So that introduces some risks as well. I think as consumers, we have to demand better security. We don't do that today, broadly, outside of this room, perhaps. When we buy a car, we look at crash safety, right? There's a level of minimum due care that you have to get on the market, but then you have star ratings and you have differentiation that we can look at and that we actually use to purchase those things. So there's a lot of areas of responsibility. Everyone has to kind of get a little bit more conversant on it. Providers of devices need to, I think, have better UX, safer defaults, so consumers can make better choices. But ultimately, it's a shared responsibility.
How difficult, and I want to hear from other folks on this too, but in that context, how difficult would it be for the technologists up here to require default passwords to be changed? I would think that's not a complex effort. And yeah, other attacks will come out, but let's at least close the screen door before we close the front door.
Exactly. That's an easy one, right? The device doesn't work until you change the password.
You get a pop-up
right?
that says...
It's a UX thing, and that falls under safer defaults.
Other thoughts on where responsibility?
I would fully agree that in an enterprise and industrial setting, it is everybody's problem. Right? In the consumer setting, we can never rely on the consumer to do any of these things. And I think if you look at Symantec consumer products and McAfee consumer security products, we moved away a long time ago from asking the consumer to make decisions on pretty much anything security related. I think we found that if we popped up something, they would just answer whichever button got them back to what they were doing the fastest they possibly could. In an enterprise setting, there's a lot more that can be done by the enterprise and by the information security team. And there's actually usually people there that understand these problems. I think in the Ukrainian example that you gave earlier, the tax software that they were downloading, there was no reason for their financial systems to have access to the same network segment where their IoT devices were. And so that was a failure on their network planning side. And we at Cisco look at that as an opportunity for our networks to get smarter around how these segments are created automatically and managed automatically. But again, in the enterprise and industrial setting, I think everybody can play a role. In the consumer setting, it's everybody but the consumer that plays a role.
Yeah, I definitely agree with Sean's point in terms of enterprises and particularly certain types of organizations that have, let's just say, access or play a more significant role in society, whether it's critical infrastructure or other types of industries, obviously have a higher standard of protection that they have to think through, even just from the basics of, have I really thought about how I segment my network, to am I really prepared? But I think in terms of, even now within IoT, when you look at how we as a society, we as consumer, and I'm talking globally, not just here in the US, but around the world, I would say for decades, most people have kind of been internet takers. What can the internet do for me? And even when you think about consumers, and I agree, you can't really necessarily rely on consumers, but when do we ask, basically society to do more for the internet? We know about Reaper. Can we have more calls out to say, hey, take, some of those cameras, offline. Do you really need them? I mean, maybe this is the time when we ask society more broadly, what can you do for the internet? Because enterprises, government aren't going to be able to do it all.
Yeah, and I know, NIST is not a regulatory agency. standards and best practices. What have you all done to address the question of who's responsible for both developing and deploying it? Do you have things in the works, or are there existing pubs out there?
So I think we have existing pubs. I think you can look at 800-160 as something that could be applicable to the pre-market situation. We have our 853. We have other documents that could be applicable post. But we are looking forward. We're starting to work on probably a NISTR that will be targeting federal agencies and helping federal agencies doing exactly that, securing their infrastructure, because we believe it's not just the device. They do need to understand the device and what they're bringing into their environment, but there's lots of things you can do to the environment because, like you said, we can never have an expectation on the device to be 100% secure.
What do we do about devices? We have, old iron machinery, some of which was developed before computers, later connected to computers that were developed before networking was a big idea, and then they're now networked before. Now, ultimately, you have several layers removed, but essentially you have 50, 60-year-old iron connected to the internet today. Can we, and then you fast forward today to a new device, which is shipped with a default, let's say a hard-coded password. What can we do to secure either end of that spectrum, or are we stuck with it when it's out there? How can we secure a device that's developed insecurely?
I'll jump in. I mean, there was a conversation I was having yesterday about actually a very similar topic, which is the idea that you have these old mainframe or legacy software that's 40 years old that was designed before there was any sort of connectivity. And basically what we're doing is we're putting wrappers around them. We're creating connections from the internet to them. And I would say that even that falls in sort of the IoT category when you talk about infrastructure and so on. It is an opportunity to. So if you just connect it and now it's internet connected, you can control it, you can interface with it in all the ways that you could if you're sitting on the local network. Clearly bad. But if you are putting a wrapper around it that provides some sort of programmatic interface or API to it, then you have an opportunity to very strictly limit how you can interact with that system, right? Now, I don't know which one of those is actually being done. People in this room might. And I imagine it's going to be a mix of both, right? Sometimes there's going to be time restrictions that are like, okay, just get this thing online. You have 30 days to do it, and the app needs to be able to access this data that was only previously accessible through these other huge systems. And in that case, you probably get more of a pass-through. If you have more time to think about it and design it securely, then I could imagine in a situation where you have like an API gateway and you more carefully control what can be passed in and out of that system. But yeah, it does present a pretty big risk there because going back to the connectedness of what you were saying about physical ramifications of things. Yeah, we have a lot of systems that are connected to physical things that are now being put on the internet, and that's sort of the other end of the spectrum of consumer devices. I think we can do it correctly. It does take a little bit more careful thought than I think maybe is being put into it today.
It's really hard to control within both current network structures and also just around the fallibility of both every single human, but just our connected lives. Because even just when you look at IoT, we've seen recently even new forms of malware that are basically kind of, I'll call it Windows Mirai, where, they might find an old piece of software, get on it, and then signal out to these new pieces, these new devices, new IoT devices. And then it's not just what can they do, around things like botnet attacks going out, but you've now got, a new army within your internal network. And so actually dinner last night, it was Vincent said a great phrase, it's almost about getting better signal to signal understanding, intelligence, connectivity. And this is where I think from a security industry perspective, we maybe haven't focused as much, which is, how do we look at not just the vulnerabilities, but also you can't control everything. So when does something look really, really bad just from a connectivity perspective? Every IoT device is calling out somewhere. All of them are connected to the internet, to the cloud. So that sort of better signal-to-signal intelligence. And I think, as Sean said, people doing hard work that you don't really want to do. Most people don't really want to exercise every day and not have dessert last night. I had a great dessert last night. But, sometimes you have to do things that are really hard, like network segmentation. And it's incredibly difficult because most networks now are more federated, are very hard to control. But I think those enterprises, organizations, federal networks that have access to really critical information or play a key role in our society have to do the hard work. And that's where it is potentially the role of regulators to say, how do we help them? How do we give them the tools, the preparation, the understanding? Because it is hard and many organizations just don't have the expertise to do it.
To the question that you asked about old machines being connected to the network, it's one of the primary use cases for IoT is just remote connectivity, remote troubleshooting. And a lot of times what we see on those is that these folks that have been working in industrial control systems for 40 or 50 years realize that rather than rolling a truck out to the factories that they need to service, they can remotely troubleshoot things. But they have no background in any sort of IT or information security. And so they'll connect these devices openly on the internet. And this is why Shodan.io does so well at finding these devices. They're literally just put up on the internet. And I think the ICS folks that are connecting them don't fully understand how easy it is to identify these and attack them. And again, I think while in this room, we probably all hear a lot about IoT and IoT security, and people get worried about Equifax or the Target hack. If you talk to people in retail about the Target hack, they're pretty aware of the fact that it went from HVAC system to the point of sale system. But if you talk to people outside of retail, they have no idea. They just assume that was a retail attack. It couldn't affect them. And so that remote connectivity piece, and really getting, again, going back to your first question of the hype, I think there's still a lot of segments of people working in connecting factories and connecting other industrial control systems that really are still completely unaware of the vulnerabilities that they're creating by doing that.
The Presidential National Security Telecommunications Advisory Committee, NSTAC, put a report out a couple of years ago that talked about this disconnect between OT, operational technology, and IT. So you're still seeing that in the field today?
Yeah, absolutely. And, I think that disconnect really just starts with, so in IT security, a lot of times we use CIA, right, with confidentiality, integrity, availability. And those are important in that order. As an IT security person, I'm happy to pull the plug on my firewall and cut off all traffic to my network if it protects the confidentiality of my data. In a factory setting, I'm not going to stop the factory line unless a human life is at risk. Yeah. And so if there's a leak of my data, so be it. Right, I'm not going to pay $20,000 to $50,000 a minute for downtime to try to stop this. And so that shift of availability being most important in a lot of these IoT scenarios really changes the way that sort of everything behaves in these environments.
Let's pretend we're in a world where IoT security is working very well. There's a good focus on it. Developers are building it in, or even a specific healthcare. There's more tension on it. There's a regulatory authority. FDA is looking at it. Do we run the risk? Do we have to balance the need to put security in with the potential downside for delaying deployment, whether it is connected cars that will avoid accidents or a new implantable medical device which will save lives? How do we do the balance between taking more time to develop to make it secure versus 500 people are going to die on the road because cars that could have stopped their own accidents, or a pacemaker that could have kept people alive? How do we balance it? And are there segments of IoT like healthcare or elsewhere where this is actually a current consideration, or is security just not even to the point that we're working on that? Anyone?
I wouldn't say in healthcare we're at the point where security is not a consideration because lives are at stake.
I meant that it is baked into healthcare in a way that it is not in other segments in consumer or elsewhere.
The FDA has certification requirements for, implantable devices. Across sort of all of IoT and really any software industry, we always say it's easier to bake in security from the start than it is to bolt it on afterwards. you should be using a secure development lifecycle. There's a million things that we say all day long. But at the end of the day, you get a 50-year-old company that's developing their widget, and they've been building this widget for 50 years, and they decide that they can improve some customer operation by connecting it to the internet. And they've never had any sort of training on software development. And they go off and buy a PLC that fits in their widget, and they connect it. It's a problematic environment where a lot of the companies that are implementing this have no background in software development and no background that would allow them to understand the ramifications of not paying attention to security from day one.
That's right. Yeah, we see that all the time. Similar situation. You can get a job developing software for consumer devices or really any software without any sort of training in this area. You can get a computer science degree without ever having to run your code through any sort of security checks throughout school. It just has to work. It doesn't have to be secure, which kind of mirrors what we see a lot of in enterprise today. So that's definitely a prevalent theme. We're getting better at that. We're starting to see more training happen in degree programs. We work closely, Verico, we work closely with a professor at Tufts who, for example, requires his students to run all of their project code through a security analyzer before they submit it, and it's part of the grade. That sort of thing is I think, the type of behavior that we want to see, because it starts to enforce early on that that's just a part of developing robust and good software. Going back to the way that you phrased the original question, how do you make those trade-offs between is it good enough to put it out there if there may be a risk, the pacemaker example, for example, if there's any possibility that something bad could happen versus the good that you could accomplish by putting it out there, how do you make that trade-off? I mean, I don't know how that works in the medical community. I do know that they make these risk decisions all the time with prescription drugs, for example. How do they do that? There's not perfection, right? There are side effects. We watch a commercial and there's like 30 seconds of somebody talking very fast about side effects. There's clearly a level of an acceptable risk that they have, that they measure against the value. And, I think we would probably do well to look at models like that as we think about similar situations for software. Now, software is maybe a little bit more unpredictable than the physiological effects of, medicine, but I don't know. I'm not a doctor either.
I was just going to add that, I don't think that we should be under any, sort of false pretenses that there's a 100% solution to this, right? And everything we do is about closing attack vectors and minimizing the attack surface on these devices and on the network surrounding them. But, as you saw with Stuxnet, even over an air-gapped network, into a very secure environment, given enough money and resources, everything is eventually attackable. And so, we really face sort of two adversaries. One is the nation-state adversary that really has unlimited time and resources. And the other one is organized crime. And the organized crime guys are not going to spend their effort somewhere where they're going to make less money than it costs them to go after it. And so we need to just keep, raising the bar as much as we can. But at the end of the day, if somebody really wants to, they're always going to be able to get into pretty much anything we do.
I think from the perspective of buying, and particularly consumers, but also enterprises, we have a huge way to go so that organizations understand that what they're buying is potentially more secure. But I think that particularly because internationally we can't control a lot of what is put on networks, particularly because most organizations are international. I think that every organization and every consumer does have to think about preparedness, in the same way that maybe this isn't the best analogy, but we think about hurricanes and power outages. We need to make sure that consumers and enterprises are more prepared for calamities that come their way from a cyber perspective. And we kind of understand it from a fire, from a physical, but I don't think that many organizations and even consumers think about, well, what happens if my internet's down? What happens if I'm, something's actually attacking, inwardly, like my home network? And And I think that preparedness is something that, potentially that we overall could address a little bit better.
And I think also as part of that preparedness, sorry,
Okay.
if you assume that something is always going to be attacked on your network, right, preventing lateral movement is the best thing you can do as an enterprise or an industrial setting. And make sure that, in the target case, if your HVAC system gets attacked, it can't move laterally to point of sale terminals or, inventory control systems or anything else that you have inside of your operation. And so, again, the network segmentation is critically important in this, and it gets overlooked all the time. And a lot of that's because of the complexity and the knowledge required to actually build that properly.
Yeah, so I was just listening to the discussions, and I think a big part of this is talking about corporate governance, because I think a lot of these decisions are made at the corporate governance level. And I think cybersecurity professionals, notoriously, we've been accused of not being able to articulate outside of our little bubble what the risks are and what the challenges are, and not being able to communicate to the board so that the board can make an informed decision about. So there are mature areas where they do know how to talk about the risks associated with the drug versus the benefits. And somebody talked earlier about the insurance models. There's lots of good insurance models and a lot of actuarial data. But when it comes to cybersecurity, I think we're just learning how to speak to the board so the board can make an informed decision and make the appropriate investments and make those trade-offs about, being first to market, close follower versus potentially, opening myself up to risks.
And I would also add that boards, especially in publicly traded companies, are very aware of the damage that that a breach like this can cause to their stock price and to their position on the board as well, right? And so
to get smaller.
You go back 5 or 6 years, and the InfoSec folks were screaming at executive management and the board, begging for resources, and now they largely understand the problem in a large enterprise. Yeah. It's still the small enterprises where they're not quite getting as much information on this.
Well, they understand that the problem exists, but it's just a big unbounded problem to them, and the point about the communication of the CISOs is definitely a big one. I mean, sometimes we talk to customer base about communicating with the board about AppSec programs, specifically since that's what we work on. And when you would ask people in the room, mostly CISO audience, to raise their hands if they brief the board of directors periodically, about 3 years ago it was 0 hands in the room. And about 6 months ago, we're up to about a third, maybe a half. That being said, of those half that actually do brief the board quarterly, you get about 5 minutes, maybe, and you get pushed off the agenda. So it becomes very difficult to, if you talk to most CISOs, IoT security and the connectedness and network segmentation, all these are not, they're top of mind, but it's probably not going to make the bullet list when they get to the board presentation. And so that does become a problem. How do you actually raise the visibility of this when you're balancing it against all the other things that you have to deal with as a CISO? It's very tough to get that visibility.
So the more you talk, the more depressing my next question gets. I was going to say, so what we've heard is that with the exception of maybe a few programs at the educational level, security is not baked in. We've heard that for a variety of reasons, most developers aren't pushing security in. I think, Chris, you said a careful thought development, you can lead to security. That's not happening. At the marketing level, consumers aren't being informed about what's secure and what's not. Consumers then are not really caring about security. And then the last point at the board level, we're up to a third asking the questions, but for maybe 5 minutes and not knowing. So 2 questions, and it's off menu. I apologize to the panelists, but where are we doing it right? And why aren't we doing it right? In other ways, how can we translate that in, whether it is to get better educational programs or beyond? Are there any lessons we can take from success stories and push it through the ecosystem?
I'll give you one piece of optimism, which is rare for me. we're seeing a lot of, so as companies are innovating more quickly and they're building more products, faster and pushing them out to market, we're seeing development methodologies change a lot. So when you were looking at waterfall models and pushing out products every year or two with a shrink wrap box, 10 or 15 years ago, you had a lot of that move to agile development, and then today you have a lot of that moving to sort of a DevOps model, where especially providers on the web, but really anybody producing software are moving towards a situation where they can push out software changes more quickly, more adeptly, both for security reasons and for functionality reasons. In the security space, software security space, we're seeing that as kind of an opportunity to get more ingrained, get plugged into the development lifecycle at places that we weren't before. So historically, it's always been at the last step. You've got something ready to release. I'll go see what the security people think about it. And you come back with a laundry list of 500 things to fix, which then the development team goes to the business to get an exception for, and then they release the product anyway. Now we have the opportunity, as developers are changing the way that they develop, the tools that they use, to really get in there early. And so even if they're not learning some of this stuff at the educational level, and they're coming in basically green, we can, for example, build a tool that sits right in their IDE where they're doing the development and call out problems to them as they are coding them, right? Hey, you just introduced a SQL injection vulnerability. Little squiggle comes underneath it. They fix it right there and then. It's reinforcing at the time they're introducing it. And if they do it again 5 minutes later, they'll get that same reinforcement. And hopefully with that repetition, you get some sort of muscle memory. As they move further along in the cycle, they're doing testing more and more often. Before you check something in, you're doing a full check. You're fixing vulnerabilities that you introduced before it goes to the rest of the, before it goes to the main code base. And so there's all these checkpoints now with modern development that I think provide an opportunity for us to do better. And we are seeing that. We're seeing that with our customers. We're seeing customers scan their software every day as opposed to every quarter. And then with the IDE situation, literally scanning continuously. Now, it doesn't solve the whole problem. There are things that you can't find that way, but there are a lot of things that you can find.
Make it harder.
You can find hard-coded passwords that way. You can find injection vulnerabilities, a lot of things that we're seeing get attacked, both in the IoT world and the web software world. So that gives me a little bit of optimism because I see the pickup in those types of techniques.
Just one more kind of brief point is we've talked a lot about like device security is important, not the whole picture. I think the bigger issue is, Jeff, as you raised about Reaper, like can we get better early warning intelligence out to everyone, both enterprises but consumers? Hey, something bad is happening, like, take your cameras offline. That, I think, is something that we do have a little bit more control over. Things become more known. How do we get that information out? And that's the other potential optimism, but also as an industry and from a regulatory perspective, is there something more tangible that we can do there?
Other thoughts?
I think there's a lot of work going on right now in industry. There are lots of consortiums. There's the Industrial Internet Consortium that's doing work. There's the Open Connectivity Foundation. There's lots of groups that are looking at this issue now and have lots of membership from private industry that are focusing on this. There's a lot of work going on in industry-led, consensus-led standards. There's work at IETF that's looking at some interesting kind of new technologies that can be. So I don't think it's ever going to be one size fits all. I don't think there's ever going to be one single bullet, but we are seeing work popping up that will, I don't know if it will happen fast enough, but that will eventually be able to put together hopefully a complete picture and secure this. So I don't think all is doom and gloom.
So last question, and I think we have a little time left for some. Okay, great. So Ari's going to have a tough one. Yeah, kind of go down the line. What is the government's role now, and what could or should it be in IoT security? And is it different if we're talking about automotive or healthcare, critical infrastructure, consumer devices? Tough one, I know, for Kat, but if you want to talk maybe about NIST role, and then we can get other folks to weigh in on what they think the government, what role it can and should play.
So within NIST, we have a responsibility to provide guidance to federal agencies on securing their infrastructures. So that is an area that I am foremost looking at right now. Is there enough guidance out there? Where are there gaps in current guidance? How can I highlight for federal agencies what they need to be thinking about when they're purchasing devices and what they need to be thinking about when they bring those in and know what the risks and vulnerabilities are around those? When it comes to the broader ecosystem, we're the National Institute of Standards and Technology. We support international standards development, and we believe, because it is a global issue, that international standards is a very useful tool in solving this. So,
Chris, thoughts?
Well, this one's filled with landmines, isn't it?
Yeah. We know what the senator thinks. So.
Yeah. Well, I think it's inevitable that there's going to be some level of government, regulation or influence over how we do things, certainly at the software level. I don't see how we get to a point where there's not something. Now, what it is and finding that balance, that I don't know. I think that there's such a range of practices and security care taken today that there's certainly room for some sort of definition of what constitutes a minimum due care, for example. You have to have certain things, but maybe we're not going to dictate exactly how you do it, which sort of aligns with what the senator said, I think. I saw, and I think this blog post was meant humorously, but I kind of like it. I was reading this guy, Troy Hunt, in the AppSec space, and he just wrote a blog post about what if IoT device, what if all consumer devices that are connected to the internet had warning labels on them the same way that we put on cigarettes, or certainly how other countries put even more prominently on cigarettes, right? That take the whole thing. What if your home device that's sitting there, your kid's toy that's connected to the internet, has a warning label that says on it, "This is a recording device, and you consent to your data being stored in an unsecured Amazon S3 bucket by turning this on." That's an extreme example, obviously, but you could apply that to anything that you buy, right? And it was meant in jest, and it's a really good post, and it's really funny, the number of the different types of devices that he creates fake warning labels for. But I think maybe there's something there. I think that, I know that the whole consumer choice thing is people are skeptical of that, but making people more aware of the risks certainly, I think, could improve the situation a little bit, and that's an area where government could come into play without actually saying, like, here, you have to make the software perfectly secure, but you have to be straightforward about what your device does and some of the risks that it introduces. I don't know, maybe there's something there.
Yeah, I agree with Chris that I think that this is a time when, is there a way that consumers have more information about what they're buying, and there's some kind of more intervention there. I think from the enterprise perspective, again, I think that there has to be a higher standard of preparation and focus among basically enterprise networks. And I think it's difficult. I think particularly in the United States, we don't tend towards more aggressive regulation. And I think you could even look at Europe, and I know they've revamped the GDPR recently to put a few more teeth in. They didn't really have very strong enforcement policies, but now when you look at the fines, they're pretty significant. But I think culturally, if we really want to change it so that people who have networks feel that sense of responsibility, I think regulation is key, because it both kind of can lead the way towards people realizing this is something they need to have a responsibility towards, but also, it can, you have to get the teeth in there somewhere. So I think particularly for networks and organizations that, can be regulated more easily, there is a pretty significant role that can be played.
So I'll actually, sorry, just to contradict you for a second. I actually don't believe that the government should ever play a role in trying to regulate a private network inside of an enterprise. I think that is very problematic. But But where the government should play a role is in anything that combines private and public infrastructure, right? So transportation is a good one, right? The roadways are owned by the public government, and the vehicles driving down them are owned by private industry, manufactured by private industry. That it makes sense that the government has to step in and help regulate that whole situation. I think in healthcare related items, the FDA is already in place to regulate things like that, and they should continue to do so in that market. For other industries, obviously when we get into industrial, the government should continue to play a role in human safety and making sure the things they're doing are not going to kill people. But as far as IoT, I'm not sure there's a lot of room in there for the government to regulate cleanly.
Go to the crowd, Ari.
So I can start with that. So we believe that the industry bodies will bring together, private industry to define what a certification would look like, and that companies that do existing certifications on software or hardware, or even the NRTLs like UL and TUV and CSA, will play a large role in certifying against industry-defined certifications. Right? These are not, to be clear, not government-defined certifications, but industry-defined certifications. And these certifications will change over time, right? As different needs arise and as different attacks come to light, we'll change as an industry as to what that certification means. But as a thing maker, the easiest place for you to certify your device is through a UL or TUV. You're already sending them your device to do electrical safety testing and an EMI and RFI and freeze thaw and whatever else you need to test it for. So to check an extra box that says also certify this particular industry standard that I'm interested in, I think is a clear path forward to get to a certification. But that being said, Cisco is involved in about 45 industry bodies that focus on IoT. I have a guy on my team that his full-time job is industry bodies and standards organization for IoT. There's 4 other people that support him, that they literally fly all over the world. So for us to find, sort of a single certification, I think is unrealistic. It's going to be more likely per market or per vertical. In the industrial space will have one, retail will probably have one, manufacturing will have one. But right now there is no single body that's really driving all of this.
I think I would agree that that the threat models and the risks and the types of attacks are going to be different per industry, like you said, and so the need for slightly different models makes sense. The only thing I would really want to add, and it really is to agree that just self-attestation is like no, does not work. You can find plenty of examples. I mean, you go to, in the security space, at least, if we look at PCI, for example, and there's a certain level of merchant where you can self-attest, and then you kind of work your way up as you get bigger. And, when it goes to like auditing some of those that have moved from self-attestation to requiring an auditor, I'm not saying it's all malicious, right? That people are just bad at assessing themselves sometimes, but I don't know that that much trust can be placed in someone to say, like, yeah, I'm doing everything right. I should have 5 stars or whatever the case may be. So not a big fan of self-attestation as it comes to security.
Other thoughts?
Sorry, real quick to add to that. On the self-attestation, you talked earlier about, static source code analysis or things along those lines. I've had companies tell me that they believe their product's secure, and I ask them about how they did vulnerability assessment, static source code analysis, did they run Metasploit or any of the known automated tools against them? Did they do pen tests? And they sort of stare at me blankly, not knowing what any of those terms mean. And then I ask, so how do you know your product's secure? And they usually say, well, we bought a chip that had a secure enclave in it, so we think we're good. Okay, the self-attestation is not going to work.
Right.
But is there maybe a place in the market for it? As long as there's transparency and the buyer's aware that this is this, and they can make a decision about whether they want to go with a product that has been self-attested to versus a product that maybe it's been attested to by a third party. Is there potentially a mixture?
I mean, if you had a way to also signal that the company that was self-attesting was clueless as to what they were self-attesting to, because I think otherwise you end up in a scenario where the same folks that are building these insecure devices today sort of stamp it and say it's good. We don't know any better.
I think the FTC may have some interest in a self-attestation world with attestations that come from clueless. I think they've already played there to some degree. Warning,
These attestations have not been verified. Really, really big.
Another question?
Good morning. Two-part question. The first is mine. The second is Harley Geiger's, and I have his proxy to ask the question. So the first...
Identify yourself.
Yeah. Hi, I'm Tim Sparapani, and I'm here on behalf of a whole bunch of clients who care about this, big, small, and in between. First part question is this. How far away are we from a remote patching system that is consumer-facing and would be helpful for consumer-facing devices? And what's the big impediment that we need to overcome to get to that point, the way that we have remote patching for other web-connected devices? And I think it's been a huge boon to security advancement personally. The second part question, which is Harley's, is will remote patching happen without government push, intervention, regulation, et cetera? Thanks.
Remote patching. Talk amongst
Yeah, so... I think it depends on the device that you're looking at. If you look at something like a Nest thermostat, it's obviously remote patching constantly. If you look at something like some of the cameras that were in Mirai, the patching was left up to the consumer. And I think even today, the majority of home residential gateways are still self-patched. And there's sort of this belief, at the network edge, at that interface between the home and the ISP, that if you automatically patch these things, the consumers are going to complain about the 30 seconds of downtime while it reboots. As if we couldn't determine the minimum, flow moment and reboot it in the middle of the night. I think that, we're seeing some interesting things with D-Link, for example, right now on the Hill. And so, it's probably making some other companies sit up and take notice. And I would expect that, self-patching, automatic patching in these devices is going to become more norm. On the consumer side, right? On the industrial and enterprise side, it's very difficult for a vendor, for a manufacturer of a thing, to say, well, this device that might be the heart of somebody's multi-billion-dollar operation is going to automatically accept and install a patch that could potentially change its behavior. Without that enterprise or industrial control system owner understanding what it does, testing it in a separate environment, and then applying it in their own schedule. And so, again, the difference between consumer and sort of enterprise industrial is very clear on this.
Yeah, that's a good distinction to make, the consumer versus the enterprise there. I mean, if you think of just as users, do we all remember when we had to actually go download a new copy of Firefox or Chrome and install it? Because 5 years ago we did. And now it is auto-patching. It just happens and the little light comes on and says, hey, an update is ready. Press this button to restart it and install it. So from the original framing of the question, is it possible? Certainly possible. The remote update, absolutely possible from a technical point of view. And most of our devices, as you pointed out, have that remote patching capability today, except for some of the older webcams and so on that just have no patching capability whatsoever. But if we're thinking about devices that we're building now and going forward, absolutely, it's a possibility. Whether we auto patch for home devices is, there's the whole supply chain risk problem there. What if the auto updating infrastructure gets owned? And so there's definitely some concern there, but it's hopefully, there are other things that can be done about that. At a bare minimum, it has to be easier for consumers to update their products. If we don't want to go full bore and just have things auto patch in the background like the thermostat, you should not have to understand how to go into the administrative console of your router and download the firmware and then use the interface to upload the firmware, and which is the case today with even the router that I bought 2 years ago. That's how you have to do it. So there's room to make things easier, even if you don't go all the way towards auto patching. I don't see where we ever get to that in the enterprise with the availability concerns and who wants to take on. As a manufacturer, do you want to take on that level of liability or even blame for taking?
Organizations just wouldn't accept.
They just no. They have to have control in the same way that we take control over Windows updates or anything else when things go down. So
I think virtualization as well. Depending on the vertical you're looking at as well, it's just not feasible when lives are at stake. You cannot automatically download a patch, not understanding what it may affect and what else might be residing on that service.
Right.
It's potentially supporting your IoT devices, but on that same machine, you have other things that may also be affected.
I just don't think you can fully lock down the attack surface of an IoT device. So both the first question about certification, yes, consumers need to, and everyone needs to be more aware of how it's been designed, absolutely a problem. Remote patching, again, a problem. But I think the biggest issue is with the innovation that comes from IoT devices, as we've seen just in general with technology, you can never lock it down. And so in a world where you can't lock it down, how do we, what are the other steps that we have to take I think is the big question, because there'll always be a way to get in, always.
On the remote patching point, though, sort of related, do you worry about this orphan device problem where you're going to have, let's say you have a great consumer device with remote patching, and then the company goes out of business, or there are any number of connected device manufacturers who are going to be gone, but the connected toothbrush or the connected hairbrush I saw at Consumer Electronics. I don't know why one would need a connected hairbrush, but you can buy one. Is that a vulnerability that's going to live on past the company, or is it going to be a onesie or twosie, or is that a legit ongoing concern we have to have? And how do we get to consumers to say, unplug your toothbrush?
No, that's a really good point that you make about the longevity of companies. A relative asked me recently, which Wi-Fi mesh product do you recommend in your home? And he listed off a bunch of them. It was Google Wi-Fi, and then 3 other companies that had produced something that I'd never heard of. And he's like, technically, the specs on these other ones are better. I'm thinking about going with, I don't remember the company name. I was like, I don't know. I would, knowing nothing about the products, I'd go with the Google one because I think they're going to be around in a few years. I think, the track record of patching and just paying attention to the security is good. I have no idea what these other companies are going to be like, if they're going to be around. Some vulnerability comes out in, some library that they're using and they're not around to patch it. Well, now I've got to go, either buy a new device or, reduce the attack surface or something. So that, I think, has to become a factor in deciding, what we use. And it's going to be a big factor because, again, who knows if that company that you backed on Kickstarter for this cool device is going to be around a year from now. Yeah, you're right.
So, but I would say beyond even the small companies that disappear over time, even within a large company, some of the major manufacturers of consumer appliances, they EOL product lines all the time. And when they end of life those product lines, they oftentimes end support for them as well. And you look at
You're operating some.
I have a dryer from a very large, appliance manufacturer that I bought in about 2010, and they decided to make it Wi-Fi connected. So it's literally it's a natural gas valve and an igniter connected to Wi-Fi, and they stopped support for it in 2013. So they haven't updated it since 2013. In case you're wondering, it's not connected to my network anymore. I disconnected it, but
you knew to do that though, and there are probably thousands of.
They stopped updating this.
What functionality did you get from your dryer by having it Wi-Fi?
Buzzes your phone when the load is done, or you can start it on your way home. Right? Like it's minimal functionality, but they basically swapped out the traditional sort of jog dial and thermocouple that makes that interaction between an igniter and a gas valve safe for an internet-connected PLC. And that internet-connected PLC had a nice touchscreen on the front and Wi-Fi connectivity and the ability to control those two separately. So, I think they saw the error of their ways because their next model didn't have Wi-Fi connectivity anymore. But then when they decided to stop supporting it, this is a dryer, right? People buy dryers that last for 10, 15, sometimes longer years. And this thing now could potentially be connected to the network and could potentially be exploited to be a bomb inside of a house. Right? It's not and this is a very large company. This is not some small Kickstarter startup.
I think we're running up against time. Is it? Yeah.
Join me in thanking the panel. Oh, you have a question? Quick question. We have maybe 3 minutes left because we're going to take the break first for logistical reasons, and then bring the next speaker on after the break. So, but why don't we take this one last question and end there, and then you can say goodbye to the panel, Jeff.
Most of us go to our kids typically too for some of the challenges with cell phones and things and apps. But I'm just thinking, they're the ones that probably should be taught this and some of the responsibilities that come with IoT. And it's kind of an interesting opportunity.
So the question is K through 12 education. Are we pushing? And it could be a number. It could be, are we pushing our kids to think about security, or are we pushing them to connect securely or code securely later on?
So within NIST, we do have the NICE program. And this is an area that they are looking at right now and they are having discussions about IoT and especially IoT security. So that is something that is being looked at.
You think it's being done in just different organizations are taking a different approach to it. The one I'm aware of, there's like an ISC squared program that's aimed at kids' education, more around just staying safe online. Not so much, again, IoT and coding, but it's at least raising the visibility and it's getting the idea in there that using social networks securely, or like the internet is forever, and those types of things, safe behaviors. But I see little programs like this cropping up within private organizations.
I think education in universities and schools is obviously important. I think the private sector play a role, potentially the public sector too. But one question, I know we've got the FTC coming and some other folks coming at some point. I would love to figure out what's the best way of consumers getting the information they need that's relevant. This manufacturer has end-of-lifed something, or, this type of an attack we're seeing. What's the best vehicle for that? Because I don't think it's 100% clear today. You're not having a consumer, go and look at different websites for this type of information. There's no easy go-to resource for consumers. And I would say for most medium-sized or even small businesses, I don't think there's an easy repository unless
even
others.
for someone who cares, how do you find out?
Consumer Reports is starting a program on IoT security and privacy, looking at rolling out something to help inform consumers. But there are challenges that they do recognize. And how do you test products for security and privacy?
Yeah, I was just going to add to the FTC notification of consumers. I mean, we've been doing food recall notices and product safety recall notices for decades now, and I think they're still largely ineffective. We constantly see on the news that, a dresser that was recalled 5 years ago just fell over on a kid because nobody found the consumer that still owned that dresser and sold them an earthquake safety strap. And so, I think it's even more problematic for an electronic device where the sort of, chain of distribution and who owns it at various points in time is really largely unknown. So it would be interesting if we could come up with something, but I think it's a bit problematic.
Thank you to the panel. Very educational. Appreciate your time today.